Hello everyone, in this video I'll be explaining the logical instructions of the 8051 instruction set. Okay, so there are total 111 instructions are present in the 8051 instruction set. So those 111 instructions are categorized or differentiated in 5 different categories. Those are data transfer instructions, arithmetic instructions, logical instructions, branch instructions, and the bit manipulation instruction. So in this video, we'll see in detail about the various logical instructions. And we all know that which are the logical operations, right? Because we have studied in the digital logic subject in third semester, that is, those are AND operation, OR operation, XOR operation, and some form of the rotate operation, and each one we'll see now. Okay, so here now these logical instructions perform bitwise operations between accumulator and the data stored in memory, register, or the data given by the program. See here in actually there are 3 parts in the instruction. So the first part is a opcode, and the second part is a destination address, and the third part is a source address. So in this point now, here the accumulator we have considered the destination address, and these things are the source address. So if the accumulator is a destination, then after the operation the result will be stored in the accumulator. From the next slide we will see that which will be the destination or different form of the instructions with respect to the addressing mode. So now first we will see the AND instruction. So the syntax for the AND instruction is ANL destination comma source. Okay, and there are total 6 different instructions are there under this AND instruction. Okay, the first we'll see the ANL A comma hash 10H. Okay, so here the destination is accumulator and the source is the immediate data. Means this instruction is associated with the immediate addressing mode. So what this instruction tells now is this processor will perform the AND operation between the contents of accumulator and the 10H. Okay, so now for reference here I have written internal RAM location. Okay, so here in the accumulator the data stored here it is 98H. So when the processor executes this instruction, the processor will get the data from the accumulator and it will do the AND operation with the 10H, and after the operation the result will be stored in the accumulator. Okay, so now we'll do the AND operation between these things. Now then I first will represent the 98H in the binary form, so that is 100. Okay, so now that is 1001. 8 is represented by 1000. And 10H is represented as 0001 and 0000, right? And we all know the AND operation, right? Means if any one of the input is 0 and the result will be 0, so it is 0, 0, 0, 0, and here it is 1 and 0, 0, 0. So what is the result now here? This is the 4 bits, it is 1 and this is 0, right? So the answer is 10H, right? Now we know that after the operation the result will be stored in the accumulator. So this now 10H will be stored here. So this 98H is overwritten with the 10H. Correct, right? So now next we'll see the next form of next opcode, that is ANL A comma address, right? So here the destination remains is accumulator, but the source data is present in the direct address. So the example is move A comma 40H. So in this, the AND operation is done between the contents of the accumulator and the data present in the 40H memory location. So now you can see that the data present in the 40H is 06H. So now we'll do the AND operation between that. So that is here, anyway this remains same. So 06H is represented like this, 0, 0, 0, 0, and this one is 1, 1, 0, right? So now do the AND operation, 0, 0, 0, 0, and this is also 0, 0, 0, 0. So what is the answer? The answer is 0, and this will be stored in the accumulator. So now here answer is stored is 0, 0, H, right? So now next third one is ANL A comma R N. So here the destination remains now accumulator, but the source data is present in the register. So this register can be any register among the 4 register bank, right? So that is from R0 to R7. So here I have taken the example as R0, that is ANL A comma R0, and as you will assume that this R0 is the register bank 0. Okay, right? So now the accumulator, here it is, the contents of the accumulator is 0, 0, 0, 0, 0, 0, 0, 0. And what is there in the R0 now? R0, the address, RAM address actually is 00H, and the data present in the R0 is 001H. So that is now 01H is 00000001, and again we get this as a 00H, and this 00 will be stored in the accumulator, right? So this again it is 00H, right? And next we'll see the fourth instruction, that is ANL A comma at RI. And this one actually it is a indirect register addressing mode, means the register acts as a pointer. And note that only R0 and R1 can be used as a pointer. So that's why here I have taken I is equal to 0 and 1. Okay, so now we'll take some different data for the accumulator. We'll take FFH. Fine. We'll take the FFH, and FFH is written as 1111111, right? So now here I'll take this RI as a 0. That is means here it is at R0. Correct, right? Now we'll see. I'll store in the R0 some address as 30H, okay, or 42H will take. Okay, so now what happens when the processor executes this instruction? It will see what is present in the R0. So now here the R0 is pointed to 42H, and processor will look into 42H, and whatever the data is present in the 42H, that will be ANDed with the accumulator. So that is now in the 42H, the data present here it is 08H, and 08H is now 08 is represented 0001000, and the answer is 0001000, that is 08H. So this 08H will be stored in the accumulator. Okay, fine. So remember that here in the indirect register addressing mode, register acts as a pointer. Next here, fifth instruction, we have ANL direct comma A. So here the destination is actually it is a direct address, and the source data will be present in the accumulator. So here the ANL 40H comma A. So the operation will be similar now. The data, whatever the data is present in the 40H, that will be ANDed with the accumulator and the result will be stored in the 40H. So now for example in the 40H, what is the data we have here? 06H, that is 000001110. And what is there in the accumulator? Accumulator we have the 08H, so that is 08H will take it as 0000100. And if we do the AND operation between this, we'll get 000H and this one will be stored in 40H. So then 40H, the result will be stored as 00. Okay, right? And next we have ANL direct comma ash data is nothing but this is the immediate addressing mode. The AND operation will takes place between the data present in the 40H memory location and the 0AH, and after the operation result will be stored in the 40H. Okay, fine. I hope this is clear. And next we'll move to OR instruction. Correct? So now same OR operation. Now here also we have 6 different the opcodes for the OR operations. That is ORL A comma ash data. This is the immediate addressing mode, means the contents of accumulator will be ORed with the FFH, right? So now I will take here data. I have taken it as FFH and the accumulator content is how much it is? 12 plus 113 means it is C, correct? So it is C, and this one is 10 means A, right? So now we'll do the OR operation between this. And OR operation, we know that if any one of the input is 1, then the output will be 1. So we get 1, 1, 1, 1, 1, 1, 1. Correct, right? So this will be stored in the accumulator. That is, the answer is FFH and that will be stored in the accumulator. Correct? So this I have taken for the earlier operation, right? And next is ORL A comma address. So here the OR operation is done between the contents of the accumulator and the data present in the direct address. And here the example I have taken it is the 52H is nothing but the OR operation is done between A and the data present in 52H. Okay. And next same again, this is the register addressing mode is nothing but the data is present in the any of the register and the accumulator, right? So and next is indirect addressing mode. The data is present like the register acts as a pointer where the data present. And next is ORL direct comma A. Here the destination is the direct address, means after the OR operation the data will be stored in 55H. Correct? So next is ORL direct comma data. Here the data is now 0AH and the data present in 55H will be all together and finally the result will be stored in 55H. Okay. In all these operations, source content remains same after the operation, but only the content of the destination address will change. Okay, right? So and next we will see XOR operation. So same thing, XOR operations. In under XOR operations also we have 6 different the instructions. The first one is XRL A comma immediate data, XRL A comma address, that is direct address, means XOR operation done between the accumulator and the data present in the 40H, and the XOR operation between the contents of accumulator and the contents of register. Here contents of accumulator and the the data present in the pointer register, and next here between the data present in the direct memory address and the accumulator. Okay, so now we'll see at least one operation or the one example how the XOR operation is done here. So here I have taken some data for the accumulator and the immediate data, and now if we do the AND operation, we know that if any one of the input is 1, then the output will be 1. Means for the different input, the output will be 1, right? So here both the inputs are same, so it is 0. Here also both the inputs are same, so it is 0, 0, 0, 0, 0, 0, 0. Correct? So means is 0. Means the answer is 0, 0, H. Correct? So now we will see the one more example for here. Here the OR operation between the contents of accumulator and 40H. We will assume that 40H is having the data 55H. Okay, that is 0, 1, 0, 1 and 0, 1, 0, 1. Okay, and accumulator will assume that we have the data FH. Okay, that is 0 FH, 0, 0, 0, 1, 1, 1, 1. So if we do the XOR operation, we get 0, 1, 0, 1, 1, 0, 1, 0. So this is here it is 55A, correct? And this will be stored in accumulator. Okay, I hope it is clear. And next we'll see next instruction under the logical group is clear instruction. Okay, so clear, the syntax for the clear instruction is clear A, means it clears the contents of the accumulator. So, right? So just assume that whatever the data is present in the accumulator earlier, after execution of this instruction, the accumulator will be accumulator content will be 0, 0, H. Okay. For example, we'll take one example here. Okay. We'll assume that first we'll take the data to accumulator as #05H, and next we will do AND operation with add a comma #0 FFH. Okay, and then we'll do move R0 comma A, and next I'll do clear A. So now what happens in this one is now first the 05H will be moved to accumulator, correct? And next the AND operation is done between the accumulator and the 0FH. So that is, if it is done 0FH, which means we'll get here 0 is represented as 0, 0, 0, 0, 0, 1, 0, 1, and this is 1, 1, 1, 1, 1, 1, 1, 1. So the answer will be now, it is 0, 5, 8. Okay, and next this one, this contents of accumulator is moved to R0, means the R0 will become now 0, 5, H. And next, and at this stage R0 is 05H and the accumulator is 05H. And the next instruction is now clear A. So after execution of this instruction, the contents of accumulator will become 0. Right? So in many situations we need this one, because A is one of the register which will be used for all the arithmetic operations. Okay, right? So and next instruction is now complement A. So complement means it will do the, like it will complement the bits of all the bits of the accumulator, means it will replace 0 by 1 and 1 by 0, right? So now for example here itself we'll take this one. Okay, I'll just remove this one, I'll write here complement A, correct? So now at this stage contents of the accumulator is 05H, that is this one, right? So after this instruction, the content will become now 0 will be replaced by 1, 1, 1, 1, 1, 0, 1, 0. Means it becomes F, A, H. That means, so it complements each and every bit of the accumulator. And now we'll come to rotate instructions. Okay. So now we have 4 different rotate instructions, that is rotate right, rotate left, with carry, through carry and direct. Okay. Now first we'll see rotate right 1 bit, right. So that is means we will be rotating the contents of accumulator 1 bit right. And note that here the rotate instruction works with only accumulate. Okay. So now we can see here this is rotate right. Okay. Means the whatever the bit is present in the LSB, that will be shifted to MSB. Means if we take this is like if because this is the 8 bit. So if I take this is D7 and this one will be D0, and after the rotate instruction this D0 will be come to D7 place and this D7 will be shifted to D6. Okay, fine. So we'll take one example here, that is move A #1. Means we are moving the immediate data to accumulator, that is 0, 0, 0, 0, 0, 0, 0, 1, right. So if I write this one as D7, D6, D5, D4, D3, D2, D1, D0, right. So rotate right means right side. This LSB which will come to this D7, right. So what happens now here? It is now 1, 0, 0, 0, 0, 0, 0, 0, right. So after the rotate operation, it is 80 H. Okay. For example, now if I do one more time, that is rotate right K. So now what happens now? This 0 will come into D7 place and this D7 will shift to D6 and D6 will be shifted to D5 and D5 will be shifted to D4. That is, we'll get 0, 1, 0, 0, 0, 0, 0, 0, 0, 8. Okay. So this is the way the rotate instruction works. Okay. And next instruction is rotate left. That is, it will shift rotate left 1 bit. Sorry. Rotate left 1 bit. Means in this the 8 bits of accumulator rotated left 1 bit. And the bit D7 exits from the MSB and enters into D0. It is just opposite to the rotate right operation, right? So for example, here I taken the example is 12H. So 12H is represented as 0, 0, 0, 1, 0, 0, 1, 0, right? So now what happens now? If I take this is D7 and this one is D0. After the rotate left operation, this MSB will shift it to LS. Correct? And now this will be shifted to this like this. And this will be shifted to like this. And this will be shifted to like this. Means we get now here it is that is 0, 0, 1, 0, 0, 1, 0, 0. So what is the answer we get after the rotate left operation is, it is 2 and this one is 4. Means it is 24H. Correct? So now take one more rotate rotate left one more time. So that is this one. Correct? This. Now first this will be shifted here. Right? So that is 0. And next this 0 will be shifted to here. 0. And next this 0 will be shifted here. 0. And this 1 will be shifted here. 1. So like that we get 0, 0, 1 0. What is the answer now? It is 48H. Correct? Right? So now this is about the rotate left operation. And next we have rotate right through carry. Right? So in the earlier operations, the carry flag is it doesn't touch the carry flag, but in this one the carry flag will be changed, means content of carry flag will be changed. Right? Now we'll see here, this we can see here, if when we do the RRC operation, the LSB will be shifted to carry flag, and the carry, whatever the bit is present in the carry flag, that will be moved to MSB. In the earlier case, whatever the data present in the LSB, that was shifted to MSB. Right? So now we'll assume that now we have moved A, #12H, and assume that the carry bit is 1. Okay, carry bit is 1. So now what is the data now? 12H means it is 0 0 1 0. Sorry, 12H means 0 0 1, and now this is 2 means 0 0 1 0. Correct now? Right? So now when we do RRC A, what happens now? This 0 is shifted to carry flag, and this carry will be shifted to MSB, that is 1. Means here 1. And this will be shifted to D6, and this will be shifted to D5. Means what happens now? Here we get 1 0 0 0 1 0 0 1. Correct? I hope it is clear. Right? And now, for example, if we do one more time, right, that is RRC A, what happens now? Here now again, this one will be shifted to carry flag, and what is there in the carry flag here? Carry flag is 0, and that 0 comes to D7, and this will be D6, D5, D4, D3, D2, D1, D0. So what we get here now? 0, 1, 0, 0, 0, 1, 0, 0, and the carry flag becomes 1. Okay. So this is about the rotate right through carry. And next is rotate left through carry. Right? So now here MSB, whatever the data bit is present in the MSB, that will be shifted to carry flag, and whatever is in the carry flag, that will be shifted to LSB. Right? So now we'll write first write the bits D7, D6, D5, D4, D3, D2, D1, D0, and the carry flag. We assume that in the carry flag we have 1. Okay. 95H is represented as 1001, and it is 0101. Right? So after RLC, the rotate left through carry, what happens? This 1 will be shifted to carry flag. That is, it becomes 1. And this carry will be shifted to D0. Correct? No? Right? So that is 1. And this D0 will be shifted to D1. And this will be shifted to D2. And this D2 will be shifted to D3, 1. And this will be shifted to D4, that is 0. And this will be shifted to D5, that is 1. And this will be shifted here, that is 0. And this will be shifted here, so it is 0. So what is the answer we got here now? It is 2. So this is 8 plus 2, 10, 11. It is 2B. Correct? No, it is 2B, and the carry flag is set is okay. And again, if we do the RLC operation, so same process will repeat. Okay. And the last most instruction under the logical instruction group is swap instruction. Okay, remember that it works only with the accumulator and it swaps the lower nibble and the higher nibble, right? And you all know that the for 4 bits we called as a nibble. Okay, see here we assume that the data is, we know the data is 8 bit and it is represented as D0 to D7, right? So if after the swap operation this D3 and D0 will come into D7 to D4 place and D7 to D4 place will come into D7 D4H. Okay, now we are considering here it is a 72H, right? That is 0110010, that is 72H. After swap instruction, what will happen? This 2 will come into this place and this 7 will come into this place. So it becomes now 27H. Okay, and all these in applications of instructions we will see in the programming part. Okay, so I hope it is clear about all the logical instructions. And one thing I want to tell that if you want to be a good programmer, you must be thorough with all the instructions set. Then only we can write the program in efficient way. Thank you.